Hello, greetings, and welcome once again to the start of our very last unit together. Can you believe we're 3/4 of the way through the course? In this final unit, we're going to deal with systems of equations, both linear and nonlinear. We're going to look at different ways to solve systems of linear equations especially. We're going to review the old methods we have of substitution and the elimination or addition method, whichever term you like to apply to it. We're also going to study something called the matrix, or the matrix, and it is an incredibly powerful tool that some of you will study in a linear algebra course on down the road, but we're going to give you a little taste for what some matrix math can look like and just a couple of the characteristics of matrices. And then to wrap things up, we're going to look at arithmetic sequences and series and talk a little bit about that. And then finally we'll wrap things up with a discussion briefly of the binomial theorem. So with that said, let me invite you to jump right in with me as we look at section 8.1 here on systems of equations. We're going to consider the graphs of two functions f and g, and we might remember that when we look at the graphs of two functions, wherever they intersect, that's where the solutions will exist. And so it's our job to find out what those points are. You guys, I think, remember how substitution and addition work. I'm going to let you pause the video at this point if you want and read through those. We're just going to jump right in here. If we look at this system, x minus y cubed equal 1 and 2x equal 9y squared plus 2, we're going to solve this top equation for x. So x equals y cubed plus 1. And then we're going to plug that in for x. So 2 times the quantity, y cubed plus 1, equals 9y squared plus 2. And so what we get here is 2y cubed plus 2 minus 9y squared minus 2. This equals 0. Alright, we'll notice our 2's drop out, so 2y cubed minus 9y squared, this equals 0. And we'll notice that we can factor out a y squared, leaving me with 2y minus 9. And we can see from here that y equals 0, y equals 9 halves. Now let's think about this. We know that x is equal to y cubed plus 1. If we let y equal 0, we come up here and plug it in, so x equals 0 cubed plus 1, x equals 1. Now we always report these using an ordered pair. So we've got the solution 1, 0. Also, we remember that y we found to also equal 9 halves. And so we're going to plug that in. X equals 9 halves cubed plus 1. When we do that work, we get 737 over 8. And that corresponds with a y value of 9 halves. Now, as step 5 says, we need to take our solutions and plug them into both equations to make sure that we indeed have a solution to the system. I'm going to let you pause the video and do that on your own. These two do work. And now we're going to move along to our next example here. What I'm going to do, you'll notice that this bottom equation here has x by itself, so I can easily rewrite this as 2y minus 4 equal x. We're going to plug this in for x, so 2y minus 4 quantity squared plus y squared equals 16. 4y squared minus, now this is 8y, double that, that's minus 16y, plus 16 plus y squared, this equals 16. Alright, so we have to combine like terms here, 5y squared minus 16y. Guys, notice we've got a 16 on both sides of the equation, so that will go away. Like before, it's relatively easy to pull out a GCF here, so we've got 5y minus 16 equal to 0. So this tells me that y equals 0 and that y equals 16 over 5. And of course, we know that once we get our values for y, 2y minus 4 equals x. We can take each of these and plug them in. 0, of course, is nice. 2 times 0 minus 4 is just simply negative 4. And so we've got the ordered pair there, negative 4, 0. And then, one more time, 2y minus 4 equal x. We're going to plug in 16 fifths. 2 over 1 times 16 fifths minus 4, this equals x. So this is 32 fifths minus 20 fifths, and 32 minus 20 we know is 12 fifths. This is my x value, and so my solution here is 12 fifths, 16 fifths. And so again, two solutions. Please go back, check both of these, make sure that both solutions here satisfy both equations. If they do, and they will, there's a solution to that particular system. One more system here to look at. Again, we see this bottom equation can be solved for y fairly easily. Y equals negative 2x minus 3. We're going to plug this in now, so we've got x squared plus parentheses negative 2x minus 3 quantity squared. This equals 1. We can expand this. We're good here. X squared plus 4x squared plus, now that's a 6x, double that, that's 12x plus 9 equal 1. We're going to combine like terms. 5x squared plus 12x plus 8 equals 0. Quadratic equation, we would factor it if we could, but checking this out, 5 times 8 is 40, and there are no two numbers that'll multiply to give me 40 and add to give me 12, which tells me this polynomial is prime. We know that when polynomials are prime, if they're quadratic, we can solve them using the quadratic equation. Now, one thing I often do before I use the quadratic equation, I might real quickly, at least in my head, check out the discriminant. Because if this discriminant turns out to be negative, as we've studied before, we know that we don't have any real solutions and we would be done. So let's see, this is 144 minus, there's 20 times 8, 20 times 8, 160. That's less than 0. So right away, if that equation has no real solutions, then we know that this system has no real solutions. So that's something that we've talked about before. We know that that's a characteristic of quadratic equations. If their discriminant is negative, it will have no solutions, and no real solutions anyway. And we can, I should probably add the word real in there, and we can proceed. So on we go to this next example. X squared plus y squared equal 4. And 6x squared plus 7y squared equal 28. Now you're looking at this thinking, now wait a minute, Kev. Wait a minute here, we have not got either one of these equations solved for x or y. This might be a little more difficult. Well, maybe. But check this out, guys. Notice that top equation, x squared equals 4 minus y squared. Alright, we're going to plug this into the bottom equation now. 6 times 4 minus y squared plus 7y squared equals 28. 24 minus 6y squared plus 7y squared equal 28. 24 plus y squared equal 28. Notice what we've got here, y squared equals 4, which means y equals plus or minus 2. Well, if y equals plus or minus 2 a minute ago, we said that x squared is equal to 4 minus y squared. Let's take these one at a time. Y equal 2, y equal negative 2. I guess we'll start with the positive. X squared equals 4 minus 2 squared. 4 minus 4 here is 0, so x squared equals 0. That means x equals 0, and so what we've got here is the solution 0, negative 2. Now again, we know that x squared equals 4 minus y squared. Alright, we're going to plug negative 2 in here for the y. X squared equals 4 minus negative 2 squared. 4 minus 4, this is 0, so we've got the ordered pair 0. You know what? We plugged in 2 over here, didn't we? That's 0, 2. This is 0, negative 2. I guess it really wouldn't have mattered. But these are my two solutions to this particular system. What questions do we have? Alright. Moving along here. You can see the problems for class discussion and for homework. Moving along, we get the opportunity, given 3 points on this graph, we get the opportunity to write the equation of this particular exponential function. Isn't that exciting? I think that's going to be pretty cool. And you're saying, well, now, Kev, we've got 3 points here. Well, yes, we do, but we've got 3 variables, and this, of course, should be f of x equal b, a to the x plus c. Probably figured that out. My apologies for the typo. Let's see what we've got here. We've got the point 0, 3. So we're going to plug that in. Let's see what that does for us. 3 equals b, a to the 0 plus c. This gives me 3 equal b plus c. And then I've got the point -1, 9. Well, let's see, where's this going to go? Well, y is 9, b, a to the -1 plus c. And maybe another way to write this, well, no, maybe about it. Another way we can write this is 9 equal b over a plus c. And then we've got the point 1, 3 halves. So y equals 3 halves equal b, a to the 1 plus c. And so, of course, this just gives me 3 halves b, a plus c. Now, what you might notice here is that this equation over here is very easy to solve for c. And so what I'm going to do is I'm going to take this 3 minus b and plug in for c. I'm going to do it right here as well. Alright, and let me switch back to the black here. So we have 9 equal b over a plus 3 minus b. And I can clear my fraction here. 9a equal b plus 3a minus ab. And here I substitute once again. 3 halves equals ba plus 3 minus b. So 3 equals 2ab plus 6 minus 2b. Now, what you'll notice, we've got 2 equations here, 1 and 2, and I can solve both of those for b. So let's see here, solve 1 and 2 for b. Alright, so we're going to subtract 3a from both sides. 9a minus 3a equals b minus ab. Now there's a level of excitement here because 9a minus 3a, we recognize we can combine like terms over here. We can factor out a b. And now when I divide both sides by 1 minus a, 6a divided by 1 minus a equals b. And then over here I'm going to do the same thing. I'm going to solve for b here. So I can subtract 6 from both sides. 3 minus 6 equal 2ab minus 2b. Once again, guys, we find a level of excitement because 3 minus 6 is negative 3. And I can factor a b out here, so 2a minus 2 times b gives me negative 3. This means that negative 3 over 2a minus 2 gives me b. And so we know, guys, coming up here now, we know that b must equal itself, which means 6a over 1 minus a must equal negative 3 over 2a minus 2. And so now, of course, we've got 6a times 2a minus 2 equal negative 3 times 1 minus a, 12a squared minus 12a equals negative 3 plus 3a, 12a squared minus 15a plus 3, this equals 0. And this will factor, of course, into 4a minus 1 times a minus 1. That equals 0. This means that a equals a quarter, and it equals 1. And, of course, if we're going to have an exponential function here, guys, we can't have a base of 1. That's not going to get us anywhere. That'd just be f of x equal b times 1 plus c. That wouldn't be exponential in any way, shape, or form. So a is a quarter. Now we know that since a is a quarter, we can plug it back in and solve for b. B equals -3 divided by 2 times a fourth minus 2. -3 divided by 2 times a quarter is a half. A half minus 2 is -3/2. And so when we do the multiplication here, we find out that b equals 2. And now once we know that b equals 2, we recall from way back over in that left-hand column that c equals 3 minus b. Got it set in there in red. So c equals 3 minus 2, which of course is 1. So the equation of this exponential function is b, which is 2, times a, which is a quarter, to the x power plus 1. And certainly I hope if you have questions about that, you'll bring those with you to class. Be happy to take a look at those. But a lot of work there, but hopefully you found, like I did, that it shakes itself out rather nicely. Let's take a look here at an application problem. It says sections of cylindrical tubing are to be made from thin rectangular sheets that have an area of 200 square inches, and we want to know, is it possible to construct a tube that has a volume of 200 cubic inches? And if it is, please find the radius and the height. Well, let's keep a couple things in mind when we're talking about a cylinder. The area of a cylinder is twice pi times the radius times the height, and the volume is pi r squared times the height. And we would like for both of these to equal a numerical value of 200, both square inches and cubic inches, respectively. Well, let's check some things out here just for a minute. If we consider this part of the equation right here, 2 pi RH equal 200, and so H is equal to 2 pi R divided by 200, or pi times the radius over 100, so that's H. Okay, and then over here, if we check this part out, 200 equals pi r squared H. Well, if we solve once again for H equals 200 divided by pi r squared. Alright, so we get the opportunity now to set our H's equal to each other. Alright, so let me clean this up just a bit here. Pi r over 100 equals 200 over pi r squared. Alright, and so I need to correct something here real quick, is what needs to happen. You guys might notice, and you probably caught this a minute ago, you're saying, wait a minute, how is this H right here equal to 2 pi r over 200? That's not right. And you're correct, that's not right. So my apologies here. Let's fix this before we get any deeper into it. And get our eraser to work here. There we are. And so, yeah. We've got H down here equal to 200 over 2 pi r. So H equals 100 over pi r there. That feels a little better, doesn't it? 100 over pi r. And so we get 100 pi r squared equals 200 pi r. Okay. And now we can work on solving for the radius. Of course, the pi's, we can divide those out. We can divide both sides by 100. And so r squared equals 2r, and r squared minus 2r equals 0. We know that r times r minus 2 equals 0. R equals 0. R equals 2. Of course, we're talking about nothing if a radius is 2. And we know we're talking about nothing if our radius is 0. And if our radius happens to be 2, we can substitute this back in over here. Height equals 100 divided by 2 pi, which is 50 over pi. So the height is 50 over pi inches. Our radius is 2 inches. And it is possible to construct a cylindrical tube that has a surface area of 200 square inches and a volume of 200 cubic inches. So you can see that there are no class discussion problems at this point, just a few to work for homework. Certainly if you have questions, bring those in and we'll be happy to take a look at those. Thank you.